Hello friends, welcome to Learner's Planet. Friends, this is our second session for coordinate geometry. In the previous session, we discussed the basics uh, related to coordinate geometry. We discussed the terminologies, basic concepts, formulae like distance formula, section formula, how to find out the area of the triangle, how to find out the coordinates of the median, all that we discussed, right? In this session, we'll be taking the problems based on coordinate geometry. And before you come for this session, you should revise the previous session. That would be really great. Okay, so let's move. Now let's take this first problem. Find the distance between each of the indicated pair of points. We have to find out the distance between these 2 points. Directly you can put up the distance formula. What the distance formula is? x2 minus x1 whole square plus y2 minus y1 whole square and the square root. Okay. Now we can directly put up the values over here. X2 is a cos beta. So it's a cos beta minus x1 is a cos alpha whole square plus a sin beta minus a sin alpha whole square and square root, right? So that is square root. Just open up the bracket. So that is a square cos square beta plus a square cos square alpha plus 2a square cos alpha cos beta plus a square sin square beta plus a square, I'm sorry, this will be minus over here, a square sin square alpha minus 2a square sin alpha sin beta. Now I'm just solving the value under the square root. So that is a square cos square beta and that is a square sin square beta. I take a square as common. So that is sin square beta plus cos square beta. Then this is a square cos square alpha and a square sin square alpha. So I take a square common, sin square alpha plus cos square alpha, and this is 2a square can be taken as common. So here it is cos alpha cos beta plus sin alpha sin beta. Now sin square beta plus cos square beta will be 1 and sin square alpha plus cos square alpha will also be 1. So this is 2a square minus 2a square cos alpha cos beta plus sin alpha sin beta, right? You can take 2a square as common, so that is root 2a. It will come outside of the square root, and then we have 1 minus cos alpha cos beta plus sin alpha sin beta, right? So this is the distance between these 2 points. Okay, so pretty simple problem, friends. You just have to put up the values of x1 y1 and x2 y2 in the formula, and just you have to solve it carefully, right? Just be very careful because you may end up making calculation errors. Okay, so just be careful about it. Similarly, we can take cos theta sin theta and sin theta cos theta. Let's see. That is cos theta sin theta and sin theta cos theta. So sin theta minus cos theta whole square plus cos theta minus sin theta whole square, right? So that's sin square theta plus cos square theta minus 2 sin theta cos theta plus cos square theta plus sin square theta minus 2 sin theta cos theta, right? So this is 1, this is 1, that means in all it is 2, minus 2 we can take common, then sin theta cos theta and sin theta cos theta, so it is 2 times sin theta cos theta, so that is 2 minus 4 sin theta cos theta, right? So this will be the distance. You can take 2 as common once again, and this will be the distance between these 2 points. Okay. Now let's see this problem. Find the value of x such that PQ is equal to QR, where P, Q and R are this and this respectively. Now PQ is equal to QR, that means what is happening? Here it's P, here it's R, and Q is the midpoint. So this is 6, 1, this is 1, 3, and this is x and 8. Now what are the midpoint coordinates? x1 plus x2 by 2, right? So 1 is equal to 6 plus x by 2, right? So 6 plus x is equal to 2, that means x is equal to minus 4. So what is the value of x? Minus 4. Simply the formula to find out the midpoint or the coordinates of midpoint we have used, nothing else. Okay. Now find the coordinates of the point which internally divides the line segment AB for the points and ratio given in. Now this is x1, y1, this is x2, y2, and this is m1 is to m2, right? Now we have to find out the coordinates of a point that divides the line joining x1, y1 and x2, y2 in the ratio 1 is to 3. So what's the coordinate? We assume x and y. So x will be m1 x2 plus m2 x1 upon m1 plus m2, and y is equal to m1 y2 plus m2 y1 by m1 plus m2, right? So m1 is, this is 1 and this is 3. So just put up the value. m1 into x2 minus 3 into 1 plus m2 x1 3 into 1 upon m1 plus m2, that is 4. So that's minus 3 and 3, that's 0, and y coordinate is m1 y2, so that is 1 into 9 plus m2 y1, that is 3 into minus 3 by 4. So that's also 0. So the coordinate of that particular point is 0, 0. That means it is actually origin. That means origin divides the line joining points A and B in the ratio 1 is to 3. Okay. Similarly, we can use the formula to find out the point, the coordinates of the point that is joining this point and this point. I'm sorry, that is dividing the line joining A and B in the ratio 2 is to 1. The same way we can do, right? So I will not do it. You can do it on your own. I hope you are clear. Now let's try this problem. Show that the following points are vertices of a square. I draw a square. Yeah. Now what are the basic properties of square? I just note down the points over here. 0, minus 2, then 3, 1, 0, 4, and minus 3, 1, right? This is P, Q, R, and S. Now, if these 4 points are vertices of square, that means PQ is equal to QR is equal to RS is equal to SP, right? PQ is equal to RS is equal to PQ is equal to QR is equal to SP. So simply put up the distance formula and find out the length of PQ, RS, QR and SP. If it is same, then definitely it will be a square. Okay. So let's do that. So here in this case, 3 minus 0 whole square plus 1 minus 4 whole square, that is 3 square. So that is 9 plus 9, 18. That means it's root 18. So that is 3 root 2. So this length is 3 root 2. Similarly, we calculate this length. So this is 3 minus 0 whole square. So that's 3 square plus this is 1 plus 2, that's 3 square. So further it is root 18. So this is also same. Similarly, it is minus 3 and square and it is 1 plus 2 square. So further it is root 18 and this is further root 18, right? So simply put up the distance formula, calculate the distance of all the four sides. If all the four sides having the same length, then it is a square. Okay. Now friends, in case of square and rhombus, in both the cases the length of all the four sides are same. But what is the difference between a square and a rhombus is the length of diagonal in both the cases is different. In this case, the length of SQ will be equal to length of PR, right? So apart from the four sides, you need to prove that PR is equal to QS. Right? Because if all the four sides are equal, then it can be a rhombus also. If it has to be square strictly, then both the diagonals should be having same length, right? So that is 3 plus 3 whole square. I just calculate PR. So 3 plus 3, that is 6 square. Then 1 minus 1. So that it is root, it's PR square is 6 square. That means PR is equal to 6. Now we calculate QS. I'm sorry, this was actually QS. Now I calculate PR. So PR square is equal to 0 and 4 minus 4 plus 2 whole square. So that is 6 square. So PR is also 6. That means PR is equal to QS. So what is happening? Both the diagonals are same, are having same length, as apart from that all the four sides are having same length. That means it is definitely a square. If it had been a rhombus, then the length of the diagonal would have been different. Okay. Now this question, the line segment joining the points A and B is trisected at the points P and Q. If the coordinates of P and Q are this, find the value of P and Q. Now let's see, I draw the line. Okay, now this is point A, that is 3 minus 4. It is point B, that's 1 and 2, and it is P, and this is Q, right? And if the coordinates of point P is P minus 2 and coordinate of Q is 5 by 3 and Q. So we have to find out the value of P and Q. Now if we take point P, it divides line AB in the ratio 1:2, right? 1:2. Okay, and Q divides the line AB in the ratio 2:1. See, this AP is equal to PQ is equal to QB. AP is equal to PQ is equal to QB. That means AP is to PB will be 1:2 and AQ is to QB will be 2:1, right? So first we find out the value of P. So here M1 and this is M2, this is X1, Y1, X2, Y2, right? So coordinates of this point P will be M1, X2. So M1 into 2 plus M2, X1, so M2 into 3 upon M1 plus M2, right? We just put up the wrong value, I'm sorry. So P is equal to M1, that is 1 into X2, that is 2, plus M2, that is 2 into X1, so that's 3 upon M1 plus M2, right? So this is 6 plus 2, 8 by 3. That is the value of P, right? Similarly, we have to find out the value of Q. Now AQ is to QB is 2:1. So this is now M1 and this is now M2, right? So we have to find out Q is the Y coordinate. So Q is equal to M2 Y1. So M2 is 1 and Y1 is minus 4, right? So 1 into minus 4 plus M1 Y2, that is 2 into 2 by 2 plus 1. So that's 0, right? So these are the values of P and Q. Apart from that, Q is actually the midpoint of P and B. So this way also we can find out the value of Q. That is -2 plus 2 by 2 is equal to Q. So that's 0, right? So anyhow you can calculate the value of P and Q, right? You can assume these two, A and Q, and P is the midpoint of A and the line joining A and Q, and in case of Q is the midpoint of line joining P and B, right? So if you don't want to use the section formula, you can calculate the values of P and Q using midpoint formula also. Okay, I hope you are clear. Now this, in what ratio the join of A and B, this is A, this is B, this is 12, 5, this is 4 minus 3, and divided by line y is equal to 2. When y is equal to, on line y is equal to 2, x coordinate will be 0. So this is 0 and 2. I assume this to be m1 and this to be m2. So we have to find the coordinates of the point of division. So coordinates of the division are 0 and 2, and we have to find out the value of m1 and m2. So then let's do it. So 0 is equal to m1 x2, so m1 into 4 plus m2 x1, so that is 12 m2 upon m1 plus m2, right? So m1, 4 m1 plus 12 m2 is equal to 0. So m1 is equal to minus 3 m2, or we can say m1 by m2 is minus 3 is to 1. So this division will be an external division. It's because of minus sign, but m1 is to m2 will be ratio as 3 is to 1. Okay, so that's pretty simple. If you are getting minus point, it will be an external division. If you are getting a positive sign, it will be an internal division, right? Now this question, find the lengths of the median of a triangle ABC having vertices this. Now I draw a triangle. Now vertices of this triangle are 0, minus 1, 2, 1 and 0, 3, right? We have to find out the length of the median. Now to find out the length of the median, first of all we need to find out the midpoint of every line, right? Now this is what? 2 plus 0 by 2 and 1 plus 3 by 2. So that is 1 and 2, right? Similarly, this is 0 plus 0 by 2. So that is 0, and 3 plus minus 1 by 2. So that is 1. Similarly, this 2 plus 0 by 2. So that's 1, and 1 minus 1 by 2. So that's 0, right? So we got the three midpoints. Now the length of the median will be using distance formula for these 2 points, and these 2 points. Okay, so distance formula for 0, minus 1 and 1 and 2. So 1 minus 0 whole square plus 2 plus 1 whole square. That is, suppose it is A, B, C, this is P, Q, R, right? So that is AP square. So AP square is equal to 1 plus 9, or we can say 10. So AP will be root 10. Okay, so length of this median is root 10. Similarly, we can calculate the length of BQ and CR the same manner. Okay, I'm sure you are able to calculate this. Let's take the next one. Now show that the midpoint of line segment joining this and this is also the midpoint of line segment joining this and this. So simple, we find out the midpoint of the line segment joining these 2 points. So that will be 5 plus 3 by 2 and 7 plus 9 by 2. So that is 8 by 2, 4 and 9 plus 7, 16 by 2, that's 8, right? Now we find out the midpoint of these two. So that is 8 plus 0 by 2 and 6 plus 10 by 2. So that is also 4 and 8. So this is also 4 and 8 and this is also 4 and 8. So we can say that the midpoint of line segment joining this point, these 2 points is same as the midpoint of line segment joining these 2 points. Okay, so this is how we can prove. Now this question, if the points this A, B, C and D are vertices of parallelogram ABCD, find the values of A and B. I first draw a parallelogram. Now this is A minus 11, this is 5B, this is 215 and this is 1 and 1. Now in case of parallelogram, the length of opposite side is same. That means this length is equal to this length and this length is equal to this length, right? So since we have to find out the value of A and B, what I can do is I find out the length of this line and I equate them. I'll be getting one relation, and then I find the length of this line and this line and equate them to get the another equation. So this is one way. Other way is the diagonal of parallelogram bisect each other. So simply what we can do, the coordinates of midpoint will be 5 plus 1 by 2, that is 3, and 1 plus b by 2. Right? Same will be the coordinates of midpoint of line joining A minus 11 and 215. So we can equate that. That means 2 plus A by 2, 2 plus A by 2 will be equal to 3. So A will be 3 2s are 6 minus 2, that is 4. Right? Similarly, minus 11 plus 15 by 2 will be y coordinate. Right? So b plus 1 is equal to 4, that means b is equal to 3. Right? So which property we have used? The diagonals of parallelogram bisect each other. That means the midpoint of this diagonal will be same as the midpoint of this diagonal. Right? So simply we can calculate. Now diagonals, both the diagonals bisect each other in all the cases: parallelogram, square, rectangle and rhombus. Now if you have to find out the difference among these four, we just discuss the difference, we'll be able to get the difference easily. I just take an example. Here I am having all the four figures, right? Now in case of square and rhombus, all the four sides are equal. So what is the difference between square and rhombus? That is the length of diagonal is not same, right? Length of diagonal in case of rhombus. That means this length is not equal to this length. Okay. If we have to find out the difference between square and rhombus, then we can find out the length of both the diagonals. If it is same, then it is a square. If it is different, then it is a rhombus. Similarly, between these two, the length of diagonal will not be same. In this case, this diagonal is not equal to this diagonal, but in this case, this diagonal is equal to this diagonal. Right? So what is the difference between rectangle and parallelogram is the length of diagonal is not same. Okay. So if you have to prove the four vertices are vertices of a rectangle, then you need to prove that the length of the diagonal is same and the length of opposite side is same, because this length is equal to this length and this length is equal to this length. Right? If length of both the diagonals is same, then it is a rectangle. If length of both the diagonals is not same, then it is a parallelogram. Right? So this is how we can differentiate among all of them. Right? In this case, all the four sides are same. In this case, the four sides are same, but diagonal length is different. In this case, sides length of opposite side is same. Here also, the length of opposite side is same, but length of diagonal is different. Okay, but in all the four cases, diagonals of all these four figures bisect each other at center. Okay, they bisect each other, but not necessary both the diagonals are equal. In this case, and this case, the diagonals are equal. In this case, the diagonals are not equal. Okay, this is main difference. So that will be really helpful for you to solve the problems. Okay. So in the next session, we'll be taking more problems from coordinate geometry. Do revise this session and the previous one so you feel more comfortable in the next session. Okay, bye-bye.